In early 2021, Pat Gelsinger returned to Intel as CEO, bringing a surge of optimism. His return was seen as a homecoming, as Gelsinger had spent 30 years at Intel before leaving to lead VMware. Gelsinger, a respected engineer and former VMware CEO, was seen as Intel's savior. His deep technical expertise and leadership experience made him the ideal candidate to steer the company through turbulent times. The company had missed key trends and faced fierce competition from TSMC and Samsung. These rivals had taken the lead in semiconductor manufacturing, leaving Intel struggling to catch up. Gelsinger outlined his strategy for Intel's revival with IDM 2.0. This ambitious plan aimed to transform Intel's manufacturing capabilities and re-establish its dominance in the industry. This plan aimed to revitalize manufacturing and expand into the foundry business. By doing so, Intel hoped to not only produce its own chips but also manufacture chips for other companies. He promised heavy investments in new facilities, technology, and talent. These investments were crucial for Intel to regain its competitive edge and innovate at a faster pace. The global chip shortage highlighted the world's reliance on a few manufacturers. This shortage underscored the importance of Intel's plans to increase its production capacity. Gelsinger saw this as Intel's chance to regain its footing. He believed that by addressing the supply chain issues, Intel could become a key player in the global semiconductor market once again. His message resonated with investors, boosting Intel's stock price. The market responded positively to his vision and the concrete steps he outlined to achieve it. Gelsinger's return marked a pivotal moment for Intel. It was a signal to the industry that Intel was ready to reclaim its leadership position. His experience and strategy offered hope for a brighter future. Employees and stakeholders alike were inspired by his clear vision and commitment to innovation. However, the path to recovery would be fraught with challenges. The semiconductor industry is highly competitive and Intel would need to execute flawlessly to succeed. The IDM 2.0 was the cornerstone of Gelsinger's plan. This ambitious strategy was designed to revitalize Intel's position in the semiconductor industry and ensure its competitiveness in a rapidly evolving market. It aimed to strengthen Intel's chip manufacturing, expand its foundry business, and diversify geographically. By doing so, Intel hoped to not only meet the growing global demand for semiconductors, but also to reduce its dependency on external suppliers. This strategy addressed several challenges facing Intel, including supply chain vulnerabilities and the need for technological innovation. It was a comprehensive approach to tackle both immediate and long-term issues. Expanding into the foundry business could diversify revenue streams, providing Intel with a more stable financial foundation. This move was seen as a critical step in reducing the company's reliance on its traditional markets. The global chip shortage highlighted the importance of semiconductor manufacturing. It underscored the need for increased production capacity and more resilient supply chains to prevent future disruptions. Governments offered incentives to boost domestic chip production. These incentives were part of broader efforts to secure national interests and reduce dependency on foreign semiconductor suppliers. IDM 2.0 required massive investments in facilities, technologies, and talent. Intel needed to build state-of-the-art manufacturing plants, develop cutting-edge technologies, and attract top-tier talent to execute this vision. Gelsinger projected the semiconductor market would double in the coming decade. This optimistic outlook was based on the increasing demand for advanced technologies, from artificial intelligence to autonomous vehicles. The strategy was met with cautious optimism from analysts. While many saw the potential for significant growth, they also recognized the challenges and risks involved in such a transformative plan. Some questioned Intel's ability to execute such a complex plan. They pointed to past difficulties and the scale of the investments required as potential hurdles. Others wondered if Intel could overcome its historical manufacturing delays. The company's track record of production setbacks raised concerns about its ability to deliver on time. Despite uncertainties, IDM 2.0 represented a clear vision for Intel's future. It was a bold statement of intent, signaling the company's commitment to innovation and leadership in the semiconductor industry. It signaled a willingness to take significant risks to reclaim its leadership. Intel was ready to invest heavily and take bold steps to ensure its long-term success. However, translating this vision into reality proved challenging. The scale of the investments, the complexity of the technologies, and the need for flawless execution were significant hurdles that Intel had to overcome. Gelsinger's arrival highlighted Intel's past missteps. Intel had dominated the PC market but missed crucial industry shifts. One major misstep was failing to capitalize on the smartphone revolution. Companies like Qualcomm and Samsung thrived, while Intel remained on the sidelines. Intel underestimated the importance of low-power mobile-first processors. Another misstep was underestimating the GPU market. NVIDIA and AMD invested heavily in high-performance GPUs, outpacing Intel. These missed opportunities showed Intel's failure to adapt quickly. Intel found itself playing catch-up in markets it had once ignored. Intel faced significant technological delays, which had a profound impact on its market position and overall reputation in the semiconductor industry. The company struggled to transition to smaller process nodes, a critical step in maintaining competitive edge and advancing chip performance. These nodes determine the size of transistors, which directly affects the performance, power consumption, and efficiency of the chips. Intel had been a leader in process technology for decades, but stumbled significantly with the 10 nanometers and 7 nanometers nodes, causing delays and setbacks. Competitors like TSMC and Samsung took advantage of these delays and leapfrogged Intel, gaining a substantial lead in the market. One of the critical missteps was Intel's hesitation to adopt extreme ultraviolet lithography (EUV) technology, which is essential for producing smaller, more efficient chips. TSMC and Samsung embraced EUV early, investing heavily in this cutting-edge technology, while Intel opted for a different approach that ultimately proved less effective. This strategic error led to further delays and hindered Intel's ability to compete effectively, causing a ripple effect throughout the industry. By the time Intel finally adopted EUV, it had lost valuable time and market share to its more agile competitors. These delays cast doubt on Intel's ability to compete in the foundry market, where speed and innovation are crucial. As a result, customers hesitated to entrust their designs to Intel, fearing further delays and technological shortcomings. Intel's IDM 2.0 strategy came with a hefty price tag. Massive investments strained the company's finances. Despite investments, Intel's revenues stagnated. The PC market matured and new markets faced stiff competition. Delays and manufacturing challenges eroded profitability. Investors grew concerned as Intel's stock price declined. The company cut dividends and announced cost-cutting measures. The financial strain showed IDM 2.0 was not paying off as planned. Intel's rivals thrived, capitalizing on the company's missteps. Intel's delays and challenges impacted customer relationships. Customers began to look elsewhere for chip manufacturing. Apple transitioned its Macs to custom-designed processors by TSMC. Other tech companies diversified their chip suppliers. This reflected a sentiment that Intel was no longer the leader. The loss of key customers like Apple hurt Intel's reputation. Once trust is eroded, it's difficult to regain in a competitive market. By late 2024, Intel faced an uncertain future. Gelsinger's departure marked the end of an era. The company grappled with missed opportunities and strategic miscalculations. IDM 2.0 strained Intel's finances without yielding expected returns. Technological delays and the loss of key customers eroded its market position. Interim leadership was in place with no clear successor. Intel's core PC market was mature, and new markets faced intense competition. The company struggled to regain customer trust. Despite challenges, Intel had significant assets. It needed to make difficult decisions about its strategic direction. Regaining technological edge and customer confidence was crucial. Intel's legacy as a tech pioneer was at stake.